Welcome back. Unit 3, Lesson 7. We are in the middle of a trigonometry unit. We have discussed angles, reference angles, coterminal angles. We've calculated or converted radians to degrees and degrees to radian measure. And we've actually started the graph sine and cosine, including moving it left, right, which is our phase shift, or up and down, which is our midline, okay? So we're going to do the same exact thing with tangent here today. We're just going to dive right into tangent and take a look at it all the way around, okay? So let's get started. All right, so before we graph tangent or do anything with tangent, let's review some trig functions on the basic unit circle. Remember, the unit circle has a radius of 1. So anytime I am here, you'll see this went 1 to the left on the x-axis, so that's why it's -1, all right? And the big thing to take away here, okay, is if this is 0 degrees, 90 degrees, 180, and so forth, a coordinate here, this coordinate is 0, 1, okay? X is your cosine, and y is your sine, all right? So, at any one of our angles, quadrantal angles, which any angle that's exactly a 90-degree increment, 90, 180, 270, 360, whatever, you can look at this coordinate and its x value will always represent the cosine of that angle. So the cosine of 90 is 0. The sine of 90 is the y value, which is 1. All right? So anytime we're on the unit circle, and I will do this in yellow. See this coordinate right here? It's on the unit circle. Whatever the x and y value are of that coordinate is the cosine and sine of this angle. All right? Now, if we knew the sides, we can do opposite over hypotenuse and so forth. But let's think about this logically. Okay? If sine is my x, doesn't my x count this way? And then if I plot at the point, the y is how many I go up. So x goes over and y goes up. So doesn't that make sense that x is your cosine and y is your sine? All right? That's kind of all stuff we should kind of be able to just put together, basically knowing that x is cosine and y is sine. All right? Now, last but not least, tangent. Tangent is a distance here. If I have my coordinate again, my point, and I draw my angle through that point, but I extend my terminal ray, that means the side where the angle ends, that purple line, all right? Well, my reference angle is always drawn to the x-axis, right? But something else is always drawn to the x-axis. If I go straight up or down from the x-axis to that line, this distance represents tangent, all right? So when they say the length of the tangent line, well, you're really just finding the tangent of your angle that's given. And tangent is tricking on Alexander, so it's opposite over adjacent, okay? So all these things are going to kind of come together. I mean, you don't have to memorize this by any way, shape, or form, but it's just a few things I just wanted to point out and kind of connect one and one, make them two, and see that they're really all related, all right? So now let's apply some of this stuff. If we're given a point, which is x and y, on the unit circle, okay, let's not forget x is cosine and y is sine, right? Then the tangent of that angle that goes through that point, well, tangent in trigonometry terms is the same thing as sine over cosine. Not sure if you remember that from Algebra 1 or whatever, maybe even geometry. And I can say if sine is y and cosine is x, tangent is the same thing as y over x because sine is my y and cosine is my x. All right? So tangent is sine over cosine, or it's y over x because sine is y and cosine is x, all right? So when they say find the following, right, the first thing we want to do is think well, tangent is opposite over adjacent, tricking on Alexander. But if it's one of those 90-degree quadrantal angles, I don't even know if I'm saying that word right. I hate that word. I can just take my sine and cosine and divide them, meaning, let's take a look at this first one here. The tangent of pi. That's the same thing as saying the tangent of 180 degrees. And my unit circle, 180 degrees is here. The coordinate is -1 on the x and 0 on the y. So my cosine is -1 and my sine is 0, right? So this is at the coordinate, -1, 0. That's my x, that's my y. Well, if tangent is sine over cosine, it's y over x, which is y over x is 0. The tangent of pi, or 180 degrees, is 0. And if we wanted to check that in our calculator, because we have calculators, if there was a finals test that said, what's the tangent of 180 or tangent of pi, you have a calculator. I hope you type it in. So let's say we are in right now radian mode. You see this right here? We're in radian mode. All right? So I'm going to put in my radians, which is pi. If I do the tangent of pi, I should get 0. And I do. All right, well, let's go to degrees. Come down here. Go to degrees. Pi is the same thing as 180. So if I do the tangent of 180, I should get the same thing because now I'm in degree mode. And I do. It's 0. All right? So let's take a look at this. The second one here, tangent of negative pi over 4. Well, I know that's the same thing as -45 degrees. So if and let me just move this out of the way quick here. -45 degrees. I know if I draw this little thing here and I go down 45 degrees, okay, I have a 45, 45, 90 triangle, which is 1, 1, radical 2. And cosine, all students take calculus, is the only positive here. So sine and tangent are negative. My answer should be negative, whatever it is. Well, tangent, this is where this comes into play. Okay, it's not a perfect quadrantal or 90-degree increment angle. Okay, I'm not going to use my points, like my x and my y for cosine and sine. I'm actually going to use opposite over adjacent. Opposite of 45 is 1. Adjacent to 45 is the other side one, and this is the hypotenuse. So tangent, which is opposite over adjacent, is really 1 over 1. And tangent in quadrant 4 should be negative. So my answer, the tangent of -45 degrees is -1. And if we wanted to check that in a calculator, and we are still in degree mode, the tangent of -45 degrees, -1. Man, we're smart. S-M-R-T. Smart, smart, smart. Let's do the next two problems here. Tangent of 150. Okay, that's not an even 90 increment. So I'm going to have to do, I can't use my coordinate. I just have to use opposite over adjacent. 150 degrees. What quadrant does that fall in? Well, 150 degrees is definitely between 90 and 180. All right, I'll do that another color just for flavor, for eye candy. All right, there we go. That's 150 degrees, which means my reference angle. You can never forget reference angles, people. Badu, 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 boo. It's 30. That means I have a 30, 60, 90 triangle. Opposite of 30 is 1. Adjacent to 30. Ooh, opposite of 30. No, I'm right, is 1. Adjacent to 30, which is opposite of 60, is radical 3. And my hypotenuse is 2. So we have opposites, adjacent, and hypotenuse, right? Well, tangent is opposite over adjacent, so it is 1 over radical 3. Is tangent positive in quadrant 2? Is it all students? No, only sine is positive. Tangent is negative. There you go. If they wanted that in simplest form, I would have to multiply the top and bottom by radical 3. If they say exact, this is exact. If they say exact and simplified, in order to simplify a fraction, we cannot have a radical in the bottom. That's why I'm going to multiply the top and bottom by radical 3, okay? So I would get negative radical 3 over 3. This is exact. Yeah, I'll be okay. Well, I can save myself. Exact. This is exact and simplified. All right. Now, if I put this in the calculator, I'm not going to get an exact answer like 1 or a half or 0. If I put this in the calculator, right, tangent of 150, bang, I do the tangent of 150 degrees. It's obviously negative, but that is not exact. That's irrational. It goes on forever. Our fractions are exact. So how would I know that that's the same? Well, let's take -1 and divide it by the square root of 3. That's what we came up with, right? That was our exact answer right here. So let's see. This answer should be the same thing as I got for the tangent of 150. And it is. Okay, it is exactly. So we're good there. All right, so we still can check that. And last but not least, I know that's the tangent. 3 pi over 2 is actually 270 degrees. That is a perfect 90-degree increment, a quadrilateral angle. Okay, so if I do this, 270 is down here on the unit circle. Remember, all these points are 1, right? I go da, 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 whatever. This is at 0 on the x and -1 on the y. So my x, my y, my cosine of 270, my sine at 270. All right? So tangent is sine over cosine, or it's y over x. My y is -1, my x is 0. Uh-oh. What happens when we have a 0 on the bottom of a fraction? Undefined. That's not 0. That's undefined. That means if I try to put the tangent of 270 in the calculator, I should get an error because it cannot be defined. All right, well, let's say tangent of 270. Let's see what the hell happened here. Boom. Error. We say go to, and it's saying, well, you can't take the tangent of 270. The error is the 270. I can do 271, get some crazy number, but I can't do 270. I can do 269, get some crazy number, but I cannot do 270 because I get an error. Clear, clear, clear. All right, good, good. So let's move on. You remember how we did this with sine and cosine? We came up with a table, and eventually from the table, we are going to create a graph. All right, we're going to do the same thing with tangent. We did this with sine and cosine already some lessons ago, and let's do this with tangent. Now, for tangent, remember, this is my x. Well, let's not worry about it. Tangent is y over x. So each one of these coordinates, okay, here, which is 1, 0, that's my x and my y. Here, which is 0, 1, that's my x, that's my y. This point, which is -1, 0, again, that's my x, it's my y. Yeah. And here, which is 0, -1, it's my x, that's my y. This is at 0 degrees and 360 degrees. This is 90 degrees, 180 degrees, 270 degrees. So let's start filling in our table, okay? So at 0 degrees, it's y over x, 0. At 90 degrees, it's y over x, undefined. All right? At 180 degrees, it's y over x, so it's 0 over -1, which is 0. At 270 degrees, we go y over x, -1 over 0, which is undefined. And of course, 360 is the same thing as 0 was. 360 and 0 are the same, so that is 0. All right? Weird. We have zeros or undefined. So let's go ahead and graph. This is my table now, okay? We found calculus by taking y over x on the unit circle. When it comes time to graph this, what goes on my x-axis and what goes on my y-axis? This represents, this column in my table represents the x's for what I'm about to graph. And this column, the bottom column, the tangent, represents the y. So in the y here, this is really whatever the tangent of my angle is, right? And the x is really just my angle. theta. Okay, so I'm going to go from 0 all the way to 360. Half of 360 is 180. Can't ever get tired of this. Half of 180 is 90. If I add 90 and 180, I get my 3/4, 270. All right? Now, tangent, if this was sine and cosine, okay, we'd have our 0. We'd go up to 1 and down to -1. All right? Now, let's plot our points. Let's start, end, and middle, just like sine and cosine. It starts at 0 degrees at a value of 0 on the y. It ends at 360 degrees at a y value of 0. So those are both on the midline. And in the middle, it's also at 0. This starts exactly like sine does. Exactly like sine does. Here's the difference, okay? Tangent is undefined at 90 and at 270. That means it could never have those values. So we do something that's called an asymptote. It's my favorite all-time mathematical word. I love it. It's a dashed line. What does that dashed line represent? Well, that means the graph will never touch it. It can get closer and closer and closer to it, but it will never actually touch it. So what does tangent do? Tangent, just like sine, starts going up, right? So it goes up and gets closer and closer and never really touches. Comes down, goes up, and then comes down. Now, the tangent of 45 is 1. So you know what? I'm going to make this a little bit better. The tangent of 45, I'm going to tell you a little secret, is 1. So that dot should kind of be there. So it should kind of like more slowly curve up. But I mean, I like to stress it, even though it might not be as accurate. As long as it kind of goes up, you're good to go. It always goes up and to the right from each dot. Here's a dot. Let me do this in another color. Here's the dot. It always goes up and to the right. Here's a dot. It goes up if I'm going to the right. Here's a dot. I'm not going to the right anymore. And as I go to the left from each dot, it goes down and to the left. So from this dot here, I don't have to go to the left. From this dot here, down and to the left. This dot here, down and to the left, okay? Now, if it was negated, those would actually flip, okay? If it was negated, I'd go down and to the rights and up and to the lefts. That would be negative tangent, but we're not doing negative tangent right now. We will eventually. Let's, come on. There you go. That's one full graph of tangent. Congratulations. All right. Graph one cycle of y equals 2 tan x from the interval. Now, I know this is going to be from -90 to +90, okay? I'm going to convert those to degrees to make them easier for myself. Okay, my amplitude is 2. My frequency, that's a 1 in front of the x, okay, is 1. My period, that's 360 divided by 1. So 360 degrees is the length of one cycle. All right. And the midline, I'm not adding or subtracting anything to it. So the midline is still at y equals 0, which is the x-axis. Now, my amplitude has no effect. I mean, the graph might go up faster or slower, but it is still going to go up, and it's still going to go up and close to your asymptotes that you draw, okay? So let's do this thing here, okay? I know I'm drawing tangent, so when I draw this, I know it's going to be like up, up, down, down, and I got these things in between, okay? So, all right? So let's draw this. If I were to draw, okay, and I'm going to extend it to the left a little bit more than I normally would. All right, let's do 360. This is where it would end. Here's 180. Here's 90. Here's 270. Here's 0. But they want me to go from 90 to -90. So I'm going to put a tab here, a tick mark, and say -90. I'll go up to 2, down to -2. That's really not going to matter at all. Okay? Now, if I'm drawing a regular tangent that ends, it starts at 0 and ends at 360, it would start at 0, it would end at 0, and the middle would be 0. My asymptotes, I know they said they're at 90 and 270, but that's just because 90 and 270 fall exactly in between those 3 dots. Okay? So if my tangent didn't end at 360, it ended somewhere else, I would still start with these 3 dots. And this is very important to know. My asymptotes are always in between these, meaning in between 0 and 180 is one asymptote. In between 180 and 360 is another. Now look it. Okay? Any dot, I go up and to the right. So I'm going to go up and to the right here. I don't have to worry about the rest of this. They only want me to graph this from 0 to 90, and from negative 90 to 90. I have gone to 90, so up and to the right. If I had to, this would go up and to the right, okay, but I don't have to. Now, every dot, I go down and to the left, okay? So this would come down to the left, but I don't need that. Down to the left, I don't need that. This would come down and to the left, and my next asymptote would be right there. So if they only want me to graph this from negative 90 to positive 90, I don't need any of this here at all. Okay? I just kind of use it just to give my bearings on how to graph and to show you visually what part of tangent we're graphing. Okay? Now it says, write the equations of the asymptotes. Okay? Well, a vertical line is always x equals. Where are my asymptotes? One is at 90. And one is at negative 90. If you want the equations, maybe you should write this. Maybe you should write x equals for both of them, because it's write the equations, plural, so you should have 2 equal signs. All right? How else could you write them? You could say there's x at pi over 2, because that's the radian version, and x equals negative pi over 2. There you go. You can write them either way, in degrees or radians. Okay? A little weird, but let's keep at it and get comfortable with it. Example 2, graph one cycle of y equals negative tan of x. All right, my amplitude is 1. My frequency is 1. That is not the absolute value bars around that, because that's the same thing as saying the negation of 1 tan of 1x. Okay, we just don't have to write the ones. So my amplitude is 1, my frequency is 1, my period is 360 divided by 1, which is 360. Vertical flip, which means instead of going up, asymptote, up, down, asymptote, down, these lines are going to flip. So I'm going to start going down, asymptote, then up to the left, down to the right, asymptote, then up to the left instead of down to the right. It is literally, if this is my midline, all of these are flipping. This one is flipping down. This flips up, and this flips down. This, oh, that was the midline. Should go through there. So down would flip up. Okay, that was bad drawing. But you're going to see I'm literally mirroring it across the x-axis, okay? So when I'm all said and done, I know, asymptote, asymptote. Instead of going up to the right, it's going to go down to the right. Okay, down to the right. Then it's going to go up to the left, up to the left. That is the flipped version. Okay, that's what my graph should look like when I'm all said and done. Let's graph it. Oh, how silly of me. My midline, I'm adding nothing, so it's still the x-axis, y equals 0. Okay, here's 360. Here's half of that, which is 180. Here's half of that, which is 90. And then 270. Okay, and we start at 0. 1, negative 1, and 0 on the y-axis. I still start at 0, and I end at 0, and the middle is 0, or on the midline, just like sine. The only difference is, yet again, in between those, if I was graphing sine, I'd have my high point and my low point, and I'd graph this S. Or in this case, it was a negative sine, I'd have my low point and my high point between my zeros. Here, it's not a low point and high point between the zeros. It's the asymptotes, okay, between the zeros. And instead of going up to the right, this is flipped. I'm going down and to the right, down and to the right, up to the left, up to the left. There you go. That's full credit. If you sketch that for me on a test, that is full credit. Well, they always got to throw a fraction in there. They always do. But you know what? It's good practice. I'm going to rewrite this. That is 2 tan. That's like saying 1/4 theta. Theta is the same thing as x. My amplitude, my frequency. My amplitude is 2. My frequency is 1/4. My period, I take 360 and divide it by 1/4. So that is basically saying I need to multiply the bottom by 4 to get rid of it. I multiply the top by 4. Yes. That's 1,440 degrees. That is the length of one cycle. Okay? Don't get freaked out. We're sketching it. It's still the same thing. We're just going to change the numbers in the bottom. That's it. Okay? My midline, I'm not adding or subtracting anything, so it's still y equals 0. All right? And this is tangent. It's not flipped, so it's going to start going up to the right, down to the left, down to. It's going to look something like that. Okay? I just like to see what I'm graphing. So let's draw our axis. Okay? So it starts at 0 and it ends at 1440. Half of that is 720. Half of that is 360. If I add 360 and 720, I get 1080. 1080 HD, baby. Love them TVs. Well, now they got that 4K high def. It's insane. Anyways, my amplitude is 2, but that's almost irrelevant for a sketch. And 0 is in between them. That's my midline. Okay. Tangent starts at 0 and it ends at 1440 at 0, or my midline. And in between them, it's also midline, just like sine. In between those 3 dots are where my motion is going to happen, either up and down if it were sine, like my mins and maxes, or since it's tangent, in between those are my asymptotes. And since this is positive, it's not negative, it's going to go up to the right, down to the left, down to the left. And there you go. That is one full curve of tangent that goes out to 1440 degrees, right? And it's positive. That is y equals 2 tan of 1/4 theta. Very good. Example 4, identify the period and where the 2 asymptotes occur for the following. Okay, before we do this, I would like to, this was in the notes earlier. I moved it toward the end for right now because it's really a repetition. It's the same thing we did for sine, same thing we did for cosine, and everything is pretty much going to be the same except the asymptotes. So before we do this, okay, identify where the 2 asymptotes occur. All right? There is a visual way to figure out the asymptotes, which is the way we've been doing it, which I think I'm most comfortable with. And there's kind of like you can do a little multiplication to figure it out. But, you know, I'm going to show you both ways, and you can pick your poison. So this was early in the notes. I just went over it because I just wanted to get right to the graphing. But if you want to flip back to the notes, here's that page, okay? I think this was following the notes right after we actually graphed tangent for the first time from that table. All right? So just like sine and cosine, my A is amplitude, okay? That is really, I don't want to say it doesn't mean anything, but it's not as relevant or important, okay? That's my amplitude, okay? That's fine. What's more important is if A is negative, or in our case, if it's less than 0, if you want to write negative, remember, that's a vertical flip. That's the big thing about amplitude when it comes to any graph, especially tangent. Frequency, that's still my B, okay? Still the number of tangent cycles or curves in 360 degrees or in 2 pi if you're doing it in radians. Okay? That is not a 6, that is an L and an E. Period. That is still, okay, that's still 360 or 2 pi divided by your frequency. I like using F instead of B. Okay, and by definition, it's the length of one cycle of tangent or one cycle of sine or cosine. Now the asymptotes, you notice there's a P in there, asymptotes. When I took this in high school or whatever, I would never pronounce that P. I'd say asymptotes. And then I got to college, and my professor, Mr. Pickering, great teacher, said, okay, we got some asymptotes. And he would really hit the P. The asymptotes, asymptotes. I'm like, what is wrong? Does he have a speech impediment that I just didn't know about? And then it hit me when I looked up the word, there's a P in it, and I'm like, he has been saying this right for the, month I've known him, and I've been saying it wrong for the past 6, 7 years. Okay, but it's asymptotes, all right? Now, they are exactly, and this is how we've been doing it on the graph, in between your zeros. And when I say zeros, I mean your 3 points on your midline, because sometimes the midline isn't on the x-axis and we can't technically call them zeros. Okay, they're exactly in between. I'm going to put this in parentheses, this little bubble here. It's exactly between your 3 points on your midline. Exactly. Okay, but if you're not graphing it, I can take my period and I can multiply it by 0.25 or 1/4. That's for the first asymptote in the cycle. And you know how there's 2? And you can also take your period and multiply it by 0.75 or 3/4. Okay? This is the algebraic way, not the visual way. There's 2 asymptotes. Here's how you get that first one, and here's how you get that second one. So how does that work? Let me go back here. Let me go back to one that's, see this 360? 360 represents 100% of my curve. Halfway mark represents 50% of my curve. Okay? Right here where this asymptote is, that's at 25% of my curve, or 0.25. So if I know what the period is, it happens to be 360, and I multiply it by 1/4, I will get 360 times 0.25. It will give me 90. And again, this happens at 75%. So if I take my period, 360, and multiply it by 0.75, I'll get 270. So I can multiply. I like to visually do it, but what the heck. So if I take, and that's an on 360 and multiply it by 0.25, that's 90. That's where my first asymptote was. If I take 360 and multiply it by 0.75, because my second asymptote is 3/4 or 75% along the way of the full curve, that's where my second asymptote happens. It should be 270, right? And it is. Okay, so we can do the same thing here. What do you think 1440, which is my period, and I multiply that times 0.25, sure enough, I'm going to get 360. If I take 1440, which is my period, and multiply it by 0.75, I'm going to get 1080. So I can do that and find my asymptotes. Okay, now if I was graphing this, I wouldn't do that. I would just put them exactly in between. But if I'm not graphing it, and I don't want to figure out what the period is, or I don't want to, I can just multiply it by 0.25 to find my first asymptote, and 0.75 to find my second one. And that's exactly what we're going to do for this example right here. Okay, identify the period. In order to find the period, I need to take 360 and divide it by my frequency, which happens to be 3. That's 120. Okay? Now, that's my period. So to find my asymptotes, I take my period and multiply it by 0.25. That's the first one. And I take that period and multiply it by 0.75. Okay? Well, this is going to end up being 30. And this is going to end up being 90. So my 2 asymptotes for this would occur at when x is 30 and when x is 90. Because remember, they're vertical lines. They go up and down. It's x equals. There you go. So let's do this next one. The first thing I'm going to do is rewrite this. That is y equals negative tan, sorry, that equal sign is sloppy, of 3/2 theta. Okay? This is my frequency. If I need to find my period is 360 divided by 3/2. Okay, well, I got to multiply this by 2/3. Multiply this by 2/3. That means I take 360 and multiply it by 2/3, right? 3 goes into 360, 120. 120 times my 2 is 240. That's my period. Okay? How do I find my asymptotes? I take my period and multiply it by 0.25. Then I take my period and multiply it by 0.75. Okay, a quarter of 240, well, if I take 240 and divide it by 4 into quarters, I get 60. And if I take 240 and I multiply it by 0.75 or 3 quarters, I should get 180 degrees. Okay, so those are my two angles. And you know what? I'm going to check that. I think that's right, but, you know, I got a calculator. Nothing worse when a student comes to me and says, hey, you made a mistake. And it's happened before. 240 times 0.25. No, that's 0.5. 25. There's my 60. And 240 times 0.75. There's my 180. Good douche. I'm smart. I'm good to go. And you know what? You're smart, and you're good to go as well, too. See you later, Destiny. All right. And now there's some homework to do. Good luck. Have at it. And I will see you at the video for Unit 3, Lesson 8. And yes, I'll see you because I've got technology that when you're watching my videos, I can actually see you watching me. It's creepy at home. I've got this, it's called I Spy. It's the name of the software. You can never see me, but I can always see you. It's very creepy. I'm just kidding. I just made that up. I can't see you. If there is a software like that, please, you know, it would be terrible. It would be such an invasion of privacy. The government probably has it already, and probably Amazon too, but not me, not Mr. Visca. All right, see ya. Have a good one.